All right, good morning, everyone. Thank you for joining me this morning, relatively early on a Friday morning. This session is all about migrating from ArcGIS Engine to the ArcGIS Runtime. My name's Mike Branscombe. I'm one of the product engineers on the ArcGIS Runtime project. We've got a number of product engineers and software developers around the world working on the ArcGIS Runtime project. I was actually reflecting on the duration and the length of time we've been working on the ArcGIS Runtime now. I think we've just passed build 2350, so we've had 2,350 daily builds of the ArcGIS Runtime since we started that. I kept this slide in, although it's the end of the week, just to talk about the organization of the runtime sessions at the DevSummit this year. And they mimic the architecture and the way we build the ArcGIS Runtime. The recordings for the sessions will be available after the DevSummit, so I kept this slide in, as will the slides also be available after the DevSummit. So the ArcGIS Runtime SDKs, multiple different SDKs for different platforms, but they all share a common architecture and core design and business logic underneath. And that really mimics the sessions. We've had a number of functional sessions that talk about all the cross-platform capabilities within ArcGIS Runtime. So when people are telling you about the offline capabilities, they apply to all of the different ArcGIS Runtime SDKs that we create. So all of the different APIs that are available all have the same capabilities. And then we've also had specific technology SDK sessions that talk about the specific capabilities of those SDKs, .NET, Java, Android, iOS, etc. And then there's also been some demo theaters, and the demo theaters were recorded as well. So there's a number of different resources available to you at the DevSummit this year. So we'll talk about the architecture in a bit more detail then. The architecture of the ArcGIS Runtime involves the creation of the business logic for the runtime, so data access, map rendering, analysis capabilities, routing, geocoding. All of that is written in our C++ runtime core. So we've got a number of engineers and teams working on that C++ runtime core code base. And then what we do is compile that for a range of different architectures and different rendering pipelines as well. So 32-bit and 64-bit, and also ARM32, ARM64. And then different range of different rendering pipelines depending on the platform that the API will be running on. And then on top of that, we actually build the ArcGIS Runtime for specific platforms. So taking Android as an example, it's compiled for both ARM32 and ARM64, and that's true for many of the platforms there. And that's actually the same component. So taking UWP as an example, the UWP runtime core DLL is the same DLL that's used in other runtime SDKs that would support UWP. So we're actually sharing not only the business logic, but even the compiled DLLs in some cases. On top of that architecture, we build the public developer SDKs that you work with. So .NET, Android, iOS, Java, and Qt. So we give you a range of different API options. Some of those are cross-platform. So taking .NET as an example, that supports Windows, UWP, Android, and iOS. Java and Qt are kind of cross-platform options as well. And then Android and iOS specifically target those platforms. So those are the ArcGIS Runtime SDKs that you download and the APIs that you develop against in that purple tier on top there. So that's the ArcGIS Runtime architecture as an overview. And then what we'll talk about in this session is migrating from Engine to the ArcGIS Runtime. So having talked about that architecture, that provides a lot of interesting options when you are migrating your ArcGIS Engine applications, because you might no longer just be thinking about moving a Windows application from Engine to a Windows application built on the runtime. The runtime opens up many new platform capabilities for you. I've spoken to people in the showcase this week who previously had an ArcGIS Engine application running on Windows, but they've chosen now to be able to build an Android application running on a tablet for their field workers. So it opens up new platform opportunities and capabilities for you. So those white boxes are essentially all of the operating systems that are supported by the ArcGIS Runtime APIs. We actually also have an additional component called the Runtime Local Server. That's supported on Windows and Linux only. And that provides additional support and kind of an extensibility point. You can actually run Python scripts within that ArcGIS Runtime local server. So think of it as a geoprocessing engine for your applications. It's only available on Windows and Linux, and that's essentially the limit of it. It will never see that on the other platforms. It's essentially based on the components that you get in ArcGIS Server or ArcGIS Pro, ArcMap. So there's a number of components, ArcGIS components in there that run and host geoprocessing tools. And they provide an interesting extensibility point, but primarily within this session, we'll talk about common functionality that's across all of the ArcGIS Runtime SDKs. And the way I've divided up the session is thought about common workflows, and actually a lot of this is based around the maps, map formats, document formats, layer types, and then some of the workflows around editing, some 3D specific considerations. One thing that I won't really address necessarily is UI design or migrating UI controls from Engine, kind of based on the fact that there are multiple different platform options. So it really depends on what platform you'd be targeting at that point. But we'll talk about primarily the concepts that are common to the ArcGIS runtime on each of those platforms. So starting with maps and data then. Within ArcGIS Engine, you'll be familiar with this. We had, through the ArcGIS 8, 9, 10 generation, the types of documents that you're working with are ArcMap documents, map packages, layer files, and layer packages. And they translate into a couple of different concepts within the ArcGIS runtime, and I'll talk about these in more detail. So taking map documents and map packages to begin with, let's take a look at online maps and mobile maps. So online maps within the ArcGIS runtime, I'm talking about essentially maps from ArcGIS Portal, the common map format across the ArcGIS platform today, essentially based on the web map spec. So ArcGIS runtime can open maps from your ArcGIS Portal. It can open maps from ArcGIS Pro. ArcGIS Pro can publish maps to Portal that can be opened in runtime. So there's a communication between all of the parts of the ArcGIS platform today based on this common map format. So you can both read and write these maps within ArcGIS Online and to and from ArcGIS Online and Pro and the runtime. I said it's based on that published web map spec, and essentially as an online map, it contains online layers and embedded content. So a feature collection, the first item there, is actually content that's embedded within the web map. So it's essentially, you can think of it as features and their geometry and attributes, but it's contained as JSON within that web map. It can also be a standalone item in the portal and then reference from the web map. So the interesting thing within the ArcGIS runtime is that feature collection is actually matched by a feature collection table, and so you can work with that table via the API as you would do any other feature data. You just have to be aware of the storage mechanism behind it being essentially JSON within the web map or JSON within a portal item. Feature layer within the map spec there, feature layer being backed essentially by a feature service hosted by ArcGIS Enterprise or ArcGIS Portal. Map image layer is essentially a map service, the map server endpoint that's published to your ArcGIS Enterprise or a map image layer within the portal. And that dynamically generates map images on request. So every pan and zoom generates a new map image. And then there's a couple of tiled layer options. These are typically your base map content, both services based in terms of in the context of the online map. So a raster tiled layer, you may be familiar with this concept, but essentially rasterized images of your data could be raster data or vector data, and then pre-generated a number of levels of detail, essentially like a pyramid. And that's available as a cached map service, and then vector tiled layer. So the kind of the new equivalent and very much better for any vector data that you're publishing, so highly optimized, much smaller footprint of the tiles, much more efficient, and also it scales well on devices with high DPI. So I talked about online maps. Let's think about mobile maps. These can come from either ArcGIS Online, ArcGIS Enterprise, or ArcGIS Pro. And the format for that is a mobile map package. The mobile map package basically contains base map content. It contains tile packages or vector tile packages. It can contain feature data within geodatabases. And then also it can contain network data sets for routing and locators for geocoding. Again, it's essentially based on the web map spec, but with extensions on top of that to support local layers within the map package. You can, there's really two approaches. If you take a mobile map package from ArcGIS Pro, you can just share it from ArcGIS Pro to the ArcGIS Runtime. In that case, it's read-only. You can also generate a mobile map package from your ArcGIS Enterprise, or ArcGIS Portal, or ArcGIS Online, and in that case, the feature data within there can be edited and synchronized back with the service that's behind that geodatabase. Okay, so that was a look at map formats. Let's take a look at data migration then. So the data formats that were supported with ArcGIS Engine, and then what the equivalents are within the ArcGIS Runtime. So the list on the left includes a range of data formats that were supported by ArcGIS Engine, from shapefiles through to service-based data. And on the right-hand side here, a number of data formats that were supported or are supported by the ArcGIS Runtime. Of course, shapefiles are still supported. Some of the new content that wasn't previously necessarily available to you, at least natively within Engine, are the mobile geodatabase that I talked about being available from a service or within a mobile map package from Pro, vector tile package, and also WFS, so WFS being natively supported within the ArcGIS Runtime at the upcoming 100.5 release. So let's go into a bit more detail about each of these data formats then. So the mobile geodatabase, .geodatabase file extension, is a database based on SQLite. One of the benefits of this is it's cross-platform. So I talked about all of the different operating systems and architectures that are supported by the ArcGIS Runtime. This mobile geodatabase works in all of those environments, from Android across iOS, Mac OS, Linux, and Windows. It's portable as a single file and efficient as well. It contains the schema data and rendering information as well. So rendering information for the feature data that's inside that geodatabase. They can come from ArcGIS Online, so either via a kind of an on-demand workflow where you connect to a service and you request an extract of that database, you download that to the client, do some editing and synchronize, or perhaps it's just a one-way download and you bring down deltas. That would be considered an on-demand workflow where you're connecting to the service in an ad hoc way. There's also a pre-planned workflow which you can configure in your portal or in ArcGIS Online, where you predetermine the map extents and the maps, or the extents of a map that will be available offline, and then you pre-generate those map packages on the server, and then the clients can just connect and download those when they're ready. So one benefit of that is it allows you to plan out the load on the server. So rather than all of your 500 field engineers connecting to the server at 9 o'clock in the morning to generate an extract to the database, you could pre-generate those map packages overnight for specific areas, and then they just download that as a file download. So when it's backed by, when that mobile geodatabase comes from a feature service, then if it's sync enabled, you can edit it and synchronize those features. And then if it's from ArcGIS Pro in a mobile map package, it's read-only. That was the mobile geodatabase format for the runtime. Let's take a look at raster data then. The ArcGIS Runtime natively supports a number of different raster formats. We use the GDAL library for raster access. There's a number of different renderers that you can apply to that, so blend, color map, hillshade. There's a number of different renderers, and they're accessible via the Runtime API. You can apply those on the fly, and if you're familiar with image server, then it's essentially a subset of the raster functions and renderers that are available with image server. Within the Runtime API, you can actually create a new Mosaic dataset from scratch, and that's creating essentially just another SQLite database on the client that acts as a catalog for the rasters that are being referenced. So mosaic datasets are a nice way of bringing together multiple raster datasets that you have on disk, and then viewing that in a kind of a seamless way within the runtime rendering engine. As well as being able to create via the ArcGIS Runtime API, there's a geoprocessing tool to create these mobile mosaic datasets as well. And then I've talked about some of the local data formats there, mobile geodatabase and raster data. The feature service is another key part of working with the ArcGIS Runtime and the ArcGIS platform. Feature services supported from both ArcGIS Enterprise and ArcGIS Online. Support a range of functionality, display, query, and editing of data, so editing of geometry, attributes, attachments. The ArcGIS Runtime API is essentially communicating with that service through the REST API. And then if they are sync-enabled feature services, that's when you can create a mobile geodatabase, download, and synchronize. Other types of services that are supported with the ArcGIS Runtime then, map and image services. So map services are dynamically rendering map images on a per request basis. They have essentially pre-configured layers and renderers. So when you're publishing your map document as a service to create a map service, you've predefined the rendering information within that service. There is actually within the map server itself, on the server side, has the capability to override that rendering information on a per request basis. So there's a dynamic layer endpoint, and then the API has capability for setting renderers on the sublayers of a map image layer. And once you start setting that rendering information on the sublayer, that's being sent to the service, and the server's rendering essentially the map that you've dynamically requested. And then image services are dynamically accessing raster imagery. The way that's implemented actually is it's bringing down the raster data, and we're working with raster data locally on the client, and that allows us to apply these rendering rules and raster functions client-side within the API without having to send that back to the service and then bring back the image that's rendered. So that was a number of different data formats that are available to you with the ArcGIS Runtime that are cross-platform. One thing I wanted to talk about as well is additional capabilities that the ArcGIS Runtime local server component provides, specifically on Windows and Linux. So some of those other data formats, if you're coming from ArcMap, and in some cases ArcGIS Pro as well, but probably in the context of ArcGIS Engine, you've been working with some of this ArcMap-based content. We'll take a look at how we can bring that into the ArcGIS Runtime using the local server component. So the local server essentially contains the objects from ArcMap, if you like. And so that allows the local server to be able to connect to maps from ArcMap or projects from ArcGIS Pro, map packages, layer files, and layer packages. It's available on Windows and Linux desktops, as I mentioned. Being available on Windows and Linux means that it's included with the ArcGIS Runtime SDKs for .NET, for Java, and for Qt. So it's not available with the ArcGIS Runtime SDKs for Android or iOS. It allows you to read map packages, and it essentially creates a local map service. So I talked about the map service running within, say, an ArcGIS Enterprise instance, dynamically rendering map images based on that content. If you open a map package via the ArcGIS Runtime local server, then it creates a local map service, and it's essentially doing the same thing. It's dynamically rendering map images from the data that it's accessed. You can also read and manipulate this content via local geoprocessing services, so you can create models or Python scripts, package those up as a geoprocessing package within ArcMap or ArcGIS Pro, and then you can manipulate that content. So you have full access pretty much to the whole Python library that's included with ArcMap or with ArcGIS Pro. Things like ArcPy.mapping for ArcMap gives you access to those map documents and layers and that content. And then that's the diagram there just shows that workflow of creating either a model with a model builder or a script, a Python script, packaging that with ArcMap or ArcGIS Pro to create a GPK or GPKX file, and then running that within the ArcGIS Runtime local server. There's the API for those three SDKs then, .NET, Java, and Qt, includes an API for essentially small-scale server administration, because you're responsible as the developer for starting and stopping local geoprocessing services or local map services. Okay, so we talked about maps and data, the common workflows and the cross-platform support and some specific options there. Let's take a look at editing as well then. So the ArcGIS Engine editing workflow mirrors ArcMap. Some of the editable data formats that you'll be familiar with are some of those geodatabase and shapefile formats. But in terms of migrating from Engine to ArcGIS Runtime then, I want to talk about some of the new options that are available, editing services, and the editable content that can come from other parts of the platform that you can edit within the runtime and then synchronize. So the editable content within ArcGIS Runtime then, feature service from ArcGIS Enterprise or ArcGIS Online Feature Services. So you're editing that content that's stored in an ArcGIS data store or a database or an ArcGIS Online. Mobile map package, you can edit geodatabase content within the mobile map package. It must have come from a sync-enabled feature service. And there's a specific API capability. The offline map sync task allows you to encapsulate a lot of functionality that would involve finer grained calls, but that allows you to create a mobile map package that you take offline, work with, and then synchronize. There are finer grained API objects, such as a geodatabase sync task if you're working with individual geodatabases, but the offline map task is more of a convenience thing because it encapsulates many of those finer grained calls for taking both feature data but also base map data offline as packages. If you're working with the mobile geodatabase specifically, again, that needs to have come from a sync-enabled feature service, and that's I talked about how you can work with that via the geodatabase sync task. The feature collections that I mentioned earlier as kind of embedded content within the map or as items, essentially via the API you work with those and you edit those exactly as you would do any other table, either a shapefile or a feature table from a mobile geodatabase. Feature collections are represented in the same way as a table object in the API. The key being that when it's time to save any edits that you've made, they're being persisted within the map as JSON, or that you're persisting those within an item in ArcGIS Online. And then the editable capabilities are, of course, editing feature geometries, editing attributes, and editing attachments. So we often talk about that as simple feature editing, and by that I just mean the distinction between the editing of features and their geometries versus being able to edit those geodatabase behaviors that you might be familiar with on top. So there's no current support for editing topologies, utility networks, or transportation networks. On the roadmap, we do have support for the utility network, and ultimately we'll be able to edit that utility network as well via the runtime API, but that's a roadmap feature. So the workflow for editing within ArcGIS Runtime then is you create or you get a feature from the table. So the table obviously knows about the schema. You request the table creates a feature. You modify the geometry, attributes, and attachments on that feature, and then you apply the edits to the table. So the table has methods for adding, updating, or deleting features. And then it's important to think about where that data is stored. So if it's within a mobile geodatabase, then the data is immediately persisted within that database, but then you need to think about synchronizing that back with the service. If you're just editing a feature layer that came from a feature service, there's an apply edits call, and that pushes the edits back up to the service. And then if you're editing a static feature collection table, then you need to think about either saving the map, and that's where the features are persisted within the map, or you need to save the portal item that feature collection came from. So let's take a look at some of the 3D specific considerations then. So in terms of when you were working with ArcGIS Engine then, through that 8, 9, 10 release cycle, the 3D content was an ArcGlobe document or an ArcScene document If you were dealing with 3D geometries or 3D features, then it was the multi-patch feature class, and you had a couple of controls available to you, the globe control and the scene control. So within ArcGIS Runtime, the document formats really mirror the formats that I was talking about for maps. So we have a web scene document, and so that's a scene that you can create within ArcGIS Online and save that in ArcGIS Online and open that within ArcGIS Runtime. Or you can publish it from ArcGIS Pro to ArcGIS Online and open that within ArcGIS Runtime. It's currently read-only within ArcGIS Runtime, but on our roadmap it would be support for being able to edit that web scene document and then push those changes back to ArcGIS Online. At our upcoming 100.5 release, we're adding support for the mobile scene package. So just like I talked about the mobile map package, mobile scene package is essentially one single file that contains that web scene document representation of the content, essentially extended web scene spec, I suppose, to reference the local content that's within that scene package, and then specific 3D layer content in there. In terms of working online, we have scene service layers, so they're published using ArcGIS Pro to either ArcGIS Online or ArcGIS Enterprise, and those scene service layers are specifically for 3D content. So you can work with regular 2D layers within 3D, as you'd expect, but there are specific 3D content types for handling 3D geometries. The offline equivalent of that scene service layer would be a scene layer package, so that's kind of a granular layer package, and again created using ArcGIS Pro, enables you to use that offline. And then when you're working in 3D, you obviously want some concept of elevation for your scene environment, and they can come from online elevation services, but also local raster data sets as well. And then one of the key features that we never had within ArcGIS Engine is this very fast GPU-based visual analysis. So view shared, line of sight, and location distance measurement, incredibly fast visual analysis. The key thing about these being they're essentially based on what's rendered at the time within the scene view. So they're 3D only, but they're also based on the resolution of the data that's available in the scene view at the time. So if you zoom in, you might get slightly different results because you get higher resolution data. If you wanted to do analysis at the full resolution of the data and persist those results, that's when you'd use something like geoprocessing, a geoprocessing operation, which would take slightly longer, but it would be operating at the full resolution of the data and would give you persistable results. Okay, so let's take a bit more of a look at analysis then. Analysis within ArcGIS Engine was based on looking at topological relationships, so some of the classic topological operator interfaces and other options in there. It also included analysis of layers using geoprocessing, and I just talked about geoprocessing within ArcGIS Runtime. And then there were specific extensions for ArcGIS Engine, and you still see this same concept within ArcGIS today. So analysis options within ArcGIS Runtime then. We have a geometry engine, so that's a class within the API for very fast, synchronous, individual geometry level operations. So it's for establishing those topological relationships. The methods operate on individual geometries, as I said. And you'll often use either a combination of these operations within the geometry engine or use them in conjunction with other areas of the API. So common things actually within the geometry engine might be projecting geometries from one spatial reference to another, or using intersect or clip to establish subsets of the geometry. ArcGIS Runtime also includes geoprocessing, so the ability to run geoprocessing operations on a server within ArcGIS Enterprise, so you can publish your own geoprocessing services to ArcGIS Enterprise, but also for the platforms or SDKs that I talked about that have the ArcGIS Runtime local server, then you can execute these geoprocessing operations locally. So having created a geoprocessing package within ArcMap or within ArcGIS Pro, you can run that within the context of the ArcGIS Runtime local server on Windows and Linux in the SDKs for .NET, Java, and Qt. And then visual analysis as well. So the interactive visual analysis tools that I talked about, viewshed, line of sight, and location distance measurement. Those are 3D only tools. But another part of visual analysis is also renderers as well. So the ArcGIS Runtime supports new renderer types that were never available in ArcGIS Engine, such as the visual variables that are available and creatable within ArcGIS Pro or ArcGIS Online. Okay, so having talked about analysis, and let's move on and take a look at routing and geocoding. So in the context of ArcGIS Engine, routing was performed on ArcGIS network datasets, required a network analyst extension, and it was executed via ArcObject or via geoprocessing. Geocoding was performed on ArcGIS locators. Talking about migrating those concepts to ArcGIS Runtime then, routing still works on an ArcGIS network dataset. It's either operating in the context of a service, so a service that you can publish or that Esri are hosting online. And these are specific optimized network analysis types or services. So routing, service area, and closest facility. And there's corresponding task classes within the API. So there's a route task, service area task, and closest facility task. But you can also execute these tasks against local data. So if you have a mobile map package that contains a network that's come from ArcGIS Pro, then you can use the same route task class against a local network dataset, and that's incredibly fast, optimized routing. Similarly for service area and closest facility. If you need more finer grained control over the network routing capabilities, or you need additional capabilities in there, you can actually use the network analysis geoprocessing tools, and you could create your own geoprocessing workflow, combining a number of tools together, either in Model Builder or Python, publish that as a geoprocessing service to your ArcGIS Enterprise, or potentially, as I talked about, using that within the ArcGIS Runtime local server component. And then geocoding, again, works with ArcGIS locators, but these are specific locators that are optimized for use within ArcGIS Runtime. And we support both the classic ArcGIS locator, but also with the upcoming 100.5 release, routing support for the new highly optimized locator that's been introduced at ArcGIS Pro 2.3. These locators, the locator task that you work with could work against either an online service, in which case it's working against the geocode server endpoint, or it can work against the locators contained within mobile map packages. Okay, so what we're taking a look at there is a number of capabilities that are common to the ArcGIS Runtime across all of the operating systems and architectures that we support, and across all of the SDKs. I talked about some capabilities that are specific to Windows and Linux within the SDKs for .NET, Java, and Qt, using that ArcGIS Runtime local server component. The other part of migrating from ArcGIS Engine to ArcGIS Runtime is actually the developer resources and the developer experience. It's completely different from ArcMap. We spend a lot of time working on the developer experience and the developer program, and you see that surfaced in the developer's website. So the ability to actually sign into the developer's website, have a dashboard, and view your information and access a range of different capabilities. So that's really the developers.arcgis.com is your starting point for working with ArcGIS Runtime. You can sign in for free, and that gives you access to your developer account and gives you a number of credits. If you need additional options, additional credits, perhaps there are pay-as-you-go plans that you can sign up to, or deployment plans that you can sign up to within the portal there, and there's an e-commerce framework there to handle that. That's where you access all the downloads for all the different SDKs. Equally, those SDKs also typically publish the API packages to whatever platform is relevant for that SDK. So in the case of .NET, we create NuGet packages, and we publish those on NuGet.org. The other APIs, such as iOS create CocoaPods, for example. So that in each case, in each SDK, they have some kind of online API repository that you work within the IDE on that platform. And then the documentation is all available within the developer's website. We do, in almost all cases, provide essentially downloadable copies of the documentation for use offline if you need to work in an offline environment. But typically we anticipate that you're working within a connected online environment, so we're continually updating that documentation throughout the release cycle. And then sample code is available through the developer's website, so the representation of the sample code, both description and you can visualize the source code. All of the samples for the ArcGIS Runtime SDKs are within individual GitHub repos, so you can clone or fork or download the repo, build the samples, and then actually work with the sample viewer and access the individual samples that way as well. And then there are tutorials, so tutorials that tie together a number of concepts and build up a workflow. We call those dev labs. They're actually broken down into data design develop, so it thinks about the data preparation side of things for the concepts that you need to know. So that's a nice part, rather than just assuming you've arrived with your own data. It actually walks you through a tutorial for how you prepare, for example, 3D content, or how you prepare a geoprocessing package for use within the ArcGIS runtime. And then there's also a toolkit as well. So some of the controls that you had available within ArcGIS Engine, we don't include those within the ArcGIS Runtime API directly. We build a toolkit on top, or we talk about it as a toolkit. And the reason for that is it's an open source GitHub repo for each SDK. And what that means is you can access the source code for that toolkit, and then you can extend the toolkit and make changes. So previously, the ArcGIS Engine UI controls were relatively constrained, not necessarily that extensible. You get the option to take that toolkit and extend it in the way you want to. The documentation then, on the developer's site, both guide documentation, so I'd encourage you to take a look at that. The guide documentation is the high-level conceptual information, but it discusses a lot of important fundamentals like the different layer types and their API representation. There's the API reference, so the screenshots on the right-hand side are all specific to .NET, because I work on the .NET SDK, but each SDK within the runtime has essentially the same architecture and layout of their developers' website, so they have the same range of tabs and the same documentation set up on there as well. The sample code, so that I talked about the sample code being available within the developer's website on a tab as a representation of that, but you can actually access the real sample code within individual GitHub repos. The example there, the URL is specifically for .NET, but all the other SDKs follow the same pattern. So they're all within the Esri organization on GitHub, and then they follow the pattern ArcGIS Runtime samples, and then the API level. There's approximately 150 samples for each platform. So for .NET, that means 150 samples for WPF, UWP, Android, and iOS. So it's quite an effort to maintain all those samples, but what they are is small, granular examples of focused API functionality. For bigger examples, we also have a demos repo. This is one thing that does vary per team, so it just depends on the team resources, but the .NET team has created a number of demos that show a variety of different concepts, such as map browsing, turn-by-turn routing, working with external GPS. So the demos repo is a great resource. And then also example apps as well. I'll talk a bit more about the example apps in a moment. The tutorials, then the dev labs, they are short, focused tutorials. I talked about the data design, develop workflow there. Typically, they are 10 to 15 minutes to complete, so they're nice bite-sized tutorials. And then in terms of support, you have a range of different support options, and there's a support tab within the developer's site that discusses the different support options. We'd always encourage you to take a look at our community forums on GeoNet. And for each of the different SDKs, there's a specific space on there. So the ArcGIS Runtime SDK for .NET example has a specific space within GeoNet, And that's a great public forum for answering questions and having discussions with either peers or with the team. So the team, the .NET team that I work on, is very active in that community and will help you out with responses to questions. But we also see great peer-to-peer interaction in there as well. The toolkit is also a major part of the SDK. So the toolkit project, I talked about, every SDK has one in a GitHub repo. Pretty much, I think some SDKs may be still working on theirs, such as the Android SDK is working on their toolkit at the moment and close to completing that. The .NET SDK released their toolkit on top of the 100.4 release back in October, November time. The toolkit contains those additional UI controls. So essentially out of the box, or the core runtime APIs include a map view and a scene view. And then the toolkit is where you'll find additional controls, such as a table of contents control, legend, compass, scale bar, scale line control. We're also looking at additional controls that we might develop in there as well, such as authentication. One thing that I'd encourage you, because these are GitHub repos, you can go into there, look at the issues, and you can click a thumbs up to upvote the issues that you'd like to see. So if there's a particular control or utility and you can see the issue in there, then I'd encourage you to vote for that. And that helps us prioritize the backlog for the toolkit. And then the open source example apps that I talked about, these are essentially full-scale applications developed by our open source example apps team, working with the ArcGIS Runtime API. They allow you to get a good head start if you can find one of the applications that's very similar to the needs that you have. They show patterns that you won't see within the samples, such as the kind of a good practice MVVM implementation, for example. Because they are built and maintained by a specific team, you can raise issues, submit issues if you find issues with those example apps. And you can help contribute as well. So perhaps you can actually fix an issue and submit a PR, and then they can review that and merge your PR. So they're a great resource, and there's a number of different example apps available across data collection. So in the plenary on Tuesday morning, you saw data collection, so collecting tree data within Portland. And what we try to do is provide these open source example apps on each platform, .NET, Android, iOS, and Qt. And in some cases, some are further ahead than others, just due to platform capabilities. Some of the SDKs, we've had more resources working on the open source example apps than others over time. But typically, we try to make sure they're available across all of the SDKs. And then let's take a look at the roadmap for the upcoming release. There's some really exciting new features coming out in just about 4 or 5 weeks, and I wanted to run through these because I think there's some key things that if you're looking at engine to runtime migration, you'll be interested in. So one of the things we're adding is support for mobile scene packages, but I think for people who have been looking at the runtime API, migrating from engine, group layer was one of the key things that people have been looking for. But also a number of additional 3D layers and subsurface navigation as well. So improving our OGC support, so adding support for the KML tour, and actually the first site of being able to override or create KML content. So we made some of the refresh properties or network links settable for KML in our upcoming release. We also added direct support within the ArcGIS Runtime API for OGC, WFS, or web feature services. And then one of the other things is support for the next generation raster tile packages, the TPKX, and those optimized new locator formats that you can create with Pro 2.3 as well. We've also been enhancing the symbology model within the ArcGIS Runtime API for much greater parity with ArcGIS Pro. And actually, we just published the Esri SIM, or cartographic information model specification, this week. And that's a published open specification for the cartographic information model, so the way we represent symbols and symbol layers and renderers within ArcGIS Pro and within ArcGIS Runtime, so across the ArcGIS platform. And then a couple of other really nice features, I think, if you're looking at migrating from engine to runtime, are reference scale for both text and symbols, and also annotation layers as well. So there was a couple of features there that we knew were preventing some people migrating from Engine to Runtime. We're really pleased to have been able to add those for our upcoming 100.5 release. Okay, so that's the end of the session. I've got the survey slide here. It'd be great if you can take the survey and give us feedback, or give me feedback on this session. Beyond that, what I found in talking to people at the conference is obviously every one of your applications is typically different. So you've got different scenarios, different functionality that you've implemented in your applications. So it's really, I'd encourage you to get in contact either personally with me. I'm around after this session to answer questions, but also on GeoNet as well. You can ask questions in there, and the entire team can help you out with any migration questions as you move from Engine to Runtime. So thank you for joining me. I've got a few minutes now to take questions before lunch. Okay, one there.
There's no direct connection to SDE data sources. Do you have to use services?
So the question is, there's no direct connection to SDE or enterprise geodatabases. That's correct. At the moment, there's no direct connection to enterprise geodatabases. It's something we're looking at implementing. It obviously has implications for a cross-platform API, Android and iOS. Typically, it's more Windows and connected environments that we'd be seeing that of interest. So it might be functionality that we're able to add on some specific platforms. Obviously, there are additional libraries that are required then as well, such as the SQL client or Oracle client. So currently, that functionality isn't in the API. It's something we're very closely investigating and trying to work out how we would implement that in the best consistent cross-platform where we can, where it's available. But the other option really is we'd encourage you to look at feature services and working with the feature services within the runtime. Another question?
In Engine we had direct access to the Windows DCs, so we could draw right to a DC and have some fun with that. Will we have access to the canvas or whatever the underlying drawing surface is?
Okay, so the question is about direct access to the renderings, or the rendering surface, or the rendering canvas within runtime. Currently, no, not within the context of our rendering surface. It is relatively constrained in that sense, I suppose, because we want to ensure an optimized, reliable, robust way. I suppose it'd be interesting to talk afterwards about specific requirements for that, and whether there's an equivalent functionality just within the core API itself, and maybe that need to write directly to the surface isn't relevant any longer because the runtime provides functionality out of the box for that. So yeah, it'd be good if we could talk afterwards about the requirements. Okay, one there.
There's really no concept of just taking a MXD and loading it up inside the runtime.
Questions. Is there any concept of just taking a map document or MXD file and loading that up within the runtime? There's not direct support for MXD documents or map documents in the runtime. The support is via content that you create within ArcGIS Pro or publish as a service via ArcGIS Online or ArcGIS Enterprise. There is, via the API, you can create a map from scratch and add layers to that and save that map and persist that map. The map format is just a JSON document, so you can persist some of that content within document, but we don't directly support the Pro project or Pro map or the ArcMap document. So it's more of a kind of authoring, publishing, and then consuming within the runtime scenario. But the API includes fine-grained access to all of the tables, so shapefile table, geodatabase feature table, and the ability to create a map and add tables and layers to the map.
I guess a follow-on to that would be, so I got an application that's, of course, my mappers in my county are using an MXD, using ArcMap, and I want an application that just runs on a desktop it's just a viewer of that MXD. Doesn't do any editing, doesn't do anything special, just a light version of ArcMap. And that's what I do inside of Engine right now. It doesn't sound really that runtime could fit for this thing.
Yeah, the question's, I suppose, continuing question about the equivalency with map documents. It's really the mobile map package would be what you would look at. So where in ArcMap you're saving a map document that references data. Within ArcGIS Pro, you'd be creating a mobile map package that essentially references the data or contains the data, and that's what you'd open within the ArcGIS Runtime. So that's the kind of parallel concept between runtime and then the opening an ArcMap document. We can talk afterwards about the, I suppose, specifics about where the data might be, how you might access that data, whether it's locally on the machine or whether it's UNC path or whether it's services-based data. All right. If there's no other questions, I appreciate you joining me today. Thank you very much. And then enjoy your lunch and the rest of the conference.